Hello and welcome. We are looking at the sheet number 2, which is labeled committees. So we looked at the pictures yesterday, where we could look at how many different ways could we order the people in the picture. Well, today we're talking about committees. Okay, so it says how many different committees of various sizes can be formed from a group of 4 members. Well, if we want a size of 4 and we only have 4 members, right, we only have one way to do that, and that is to take everybody from that committee, right? So it says, how about a committee of size 3? Well, let's think about this. If we label our people, right, person 1, person 2, person 3, person 4, right? So for the committee size 4, the only way to do it is to have all 4. Well, if we have 3 people in our committee, we could take 1, 2, and 3. We could take 1, 2, and 4. We could take 1, 3, and 4. Okay, or we could take 2, 3, and 4. So this one leaves out 4, this one leaves out 3, this one leaves out 2, this one leaves out 1. So there are 4 different committees that could be made, right, if you have groups of 3. So sorry if that was a little confusing when I put in some of those commas there. I probably should have only put the comma where we're going to actually have the break in the group. So now if we look at the breaks, and if we have size 2, well, I could have 1 and 2, I could have 1 and 3, I could have 1 and 4, I could have 2 and 3, I could have 2 and 4, and then I could have 3 and 4. So that's 1, 2, 3, 4, 5, 6. Okay, if I only want 1, well then I could have just 1 by himself, just 2 by themselves, just 3 by themselves, and just 4 by themselves. So there are 4 different committees that I could have by 1. And then if I'm looking at a committee size of just 0, well there's only one way to take no one, and that's to take nobody. Okay, so it says if another person joins the group, how many committees of sizes 5, 4, 3, 2, and 1, and 0 can be formed? Okay, so we have to use the same basic idea that we used up here, only now we're looking at 5, 4, 3, 2, and 1. So if we're looking for a 5-person committee, we know that there's only one way to take all 5 people, right? If we want to look at a 4-person, right, committee, then we could take one person out, right? And we could take one person out, each one of those 5 people out. So we could have one group that was 1, 2, 3, and 4. We could have a group that was 2, 3, 4, and 5. We could have a group that was 1, 2, 3, and 5. We can have a group that is 1, 3, 4, and 5. So we took out person 5, we took out person 4, we took out person 3, we took out person 1. Oh, I missed one. We never took out we took out 2 here. So we took out 1, 2, I never took out person 3. So 1, 2, 4, and 5. That takes out 3. So that gives us 5 for a 4-person committee. Now when I want to do the 3-person committee, okay, this one is going to have a little bit more. Okay, so the 3-person committee, I'm going to come over here and I'm going to do the same thing. Okay, for my 3-person committee, so I could have it be 1, 2, and 3. I could have it be 1, 2, and 4. I could have it be 1, 2, and 5. Okay, so those are all the different combinations I could have that have 1 and 2. So now I go to 1, 3, and 4, and I could have 1, 3, and 5. And I already have 1, 2, and 3, right? So then I go on to 1, 4, and 5. Okay, and then, so these are all the ones that include 1, right? But then I have to take 1 out. So now I could have 2, 3, and 4. I could have 2, 3, and 5. Okay, then I could take 3 out and do 2, 4, and 5. Okay, now I can take out 1 and 2, so then I would have 3, 4, and 5 left. So then I go through and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. Oops. So I can have 10 3-person. Okay, and then when I go to my 2-person, okay, I could have 1 and 2, I could have 1 and 3, I could have 1 and 4, I could have 1 and 5. Okay, then I can go to my 2s. I could have 2 and 3, 2 and 4, 2 and 5. Then I could have 3 and 4, 3 and 5. Did I forget one? Oh, I forgot 4 and 5, right? Got to get to that last one of 4 and 5. So that gives me another 10. Okay, so then when I go to my 1-person, right, we know that there's going to be 5 because we can select each one of the 5 individual members. And if I have 0 people in it, right, I have a 0-person committee, there's only one way to do that, which is to draw none of them. So hopefully, right, when we look at this, right, we can see that there's a pattern that exists, right? We went 1, 4, 6, 4, 1. Here we went 1, 5, 10, 10, 5, 1. So we know that something has to exist here, right, that shows us this pattern. What is it going to be? Now, we learned on the previous ones, right, that we had the factorials involved. So we had both the number of people that we had to select from. We had the number of people that we were going to select, right? And now this time, because order doesn't matter, right, we have something else that must come into play also. Okay, so we have these different things that are here. Okay, so what we're going to look at is, okay, well, if we have 5 people, or let's look at the first one, right? So we have 4 people, right? We know that if we're selecting 2, okay, so we have 4 people and we want to select 2. So then before we would do 4 over 4 minus 2. Well, 4 factorial over 4 minus 2 factorial, right? But when we do that, that would give us 4 times 3 is 12, times 2 is 24, times 1 gives us, right, 24. This would just give us 4 minus 2, which would be 2 factorial, which would just be 2, so that would get us down to 12, but we said we needed to get this down to 6. Well, what if I take that 2 that I already subtracted by and I add that factorial out in front? So what if I had a 2 factorial out in front? Right, because that will give me another 2, which now gives me 24 divided by 2 factorial times 2 factorial, which is just 2 times 2, which gives me that 6 that I'm looking for. Okay, so let's see if it works for another one. Well, if I have 4 and I want to select, let's say, 3 of them, right, then that would be 3 factorial and then times 4 minus 3 factorial. Okay, so here, right, if I had 4 factorial would give me 4 times 3 times 2 times 1, which is my 24 again. My 3 factorial would just give me 3 times 2, which is 6. Okay, and then my 4 minus 3 would be times 1 factorial, right, which is just 1. So 24 divided by 6 is 4. Okay, so that seemed to work. So now let's test it on our 5. Okay, if we have these groups of 5. So we know that there's going to be 5 for 4-person. We know there's going to be 10 for 3-person groups. So let's test those two out. So if I do 5 factorial, and then I'm going to take, I think I said we were going to do the 4-person. So this is, we're taking 4 away. So 4 factorial, and then times 5 minus 4 factorial, right? That leaves us with 5 factorial over 4 factorial times 1 factorial. Now, we haven't really done a whole lot of this, right? But this would be the same as 5 times 4 factorial all over 4 factorial. So then those would cancel each other out and we're just left with 5. let's try it for the 3-person group. So we have 5 factorial over 3 factorial times 5 minus 3 factorial. So again, we could write this, right? This 5 minus 3 is really 2 factorial. So we could write this as 5 times 4 times 3 factorial over 2 factorial times 3 factorial. So we could cross off the 2 3 factorials, the one on top and bottom, and then we'd be just left with 20 over 2, which gives me that 10. So we seem to have found a winner, right? When the order doesn't matter, okay, we can take the total number of people that we're looking at, factorial, divided by the number that we're pulling out for the group, and multiply it by the total number minus the amount we want for the group, factorial. So n factorial over r times n minus r factorial. So this is what we're going to use when our order doesn't matter. So hopefully that helped clarify some things up for you guys. Hopefully you're having a wonderful night. And if you have any questions, just let me know. Thanks a lot, guys.